Today we're taking notes on day 9, which is section 6, use proportionality theorems. We're going to learn 3 different theorems, and then we're going to do some examples applying those theorems. The first theorem is the triangle proportionality theorem. This theorem says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So let's see what that's really saying. If a line is parallel to one side of a triangle, okay, we have that BE is parallel to CD. Then it intersects the two sides, that's true. Our intersection points are B and E. Then it divides the two sides proportionally. So here's the proportion that we're going to get, if you could write this down with me. AB over BC, so top over bottom, that's going to be proportional to AE top over ED. Converse is also true. So if this proportion is true, then BE is parallel to CD. So let's look at an example. So example number 1 goes off of that same figure. Gives us some information. It says in the figure below, BC is 9. So I'm going to label all this. AE is 4. ED is 6. Find the length of AB. Okay, first thing, I want to write the proportion. So AB over BC is equal to AE over ED. It's really important that you write this for me. Don't just jump to the numbers so I kind of can see where you're going. Now let's fill in what we know. AB we called X. BC we called 9. AE is 4. And then ED is 6. Now we want to do the cross products property. 9 multiplied by 4 is 36. 6 multiplied by x is 6x. So we get x is equal to 6. So in this case, AB is 6 units. Okay, so let's go on. We're going to do 2 more theorems. This theorem says if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So we have our 3 parallel lines, parallel, parallel, parallel. Our 2 transversals, which are L and M. So the transversals are divided proportionally. So let's write the proportion. UW, that's this one, goes with WY. That's going to be proportional to BX over XZ. So this first ratio goes with our first transversal, UW over WY. Second ratio goes with the second transversal, VX over XZ. So let's see an example. Second theorem, then we're going to do some examples. This theorem says if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other 2 sides. Okay, this one is definitely more complicated than the first 2 that we did. So if a ray bisects an angle of a triangle, so let's mark that. Let's say that angle B is bisected. It's cut into 2 congruent angles. It divides the opposite side. So our opposite side here is AC into segments whose lengths are proportional to the lengths of the other 2 sides. Okay, so we're going to have a proportion. We have to use those 2 parts of AC. So those 2 parts are AD and DC. The other 2 sides that go in this proportion are the other 2 sides of the triangle. AD touches side AB. So in our proportion, AD is going to go over AB. DC connects with side BC. So DC will go over BC. Okay, we have 3 examples that we're going to do. Here's the second example. I would like you to try this one. Label the figure, set up a proportion, and solve. You will get a fraction for an answer. And then come back when you've solved the problem. Welcome back. I hope that you've actually tried this problem. First thing that I'm going to do is label the figure. It says AB is 17 BC is 11. DE is 3x subtract 2. And EF is 5x subtract 6. So this goes with the second theorem that we wrote down because we have 3 parallel lines. First thing that I'm going to do is write my proportion. So I have AB over BC. That's going to be proportional to DE over EF. Now I'm going to fill it in. 17 over 11 is proportional to 3x subtract 2 all over 5x subtract 6. Okay, now we're going to do our cross products. 11 is going to be multiplied by 3x subtract 2. 17 is going to be multiplied by 5x subtract 6. Distributing, I have 33x subtract 22. That's equal to 85x subtract 102. I'm going to continue my work up here. First thing that I'm going to do is I'm going to subtract 33x from both sides. So I have negative 22 is equal to 52x subtract 102. Adding 102 to both sides, I have 80 is equal to 52x. Dividing by 52, I get x is equal to 80 over 52. Please simplify this. Both 80 and 52 are divisible by 4. So this simplifies to be 20 over 13. So I hope you got that one right. Here's our next example. I would like you to try this one. Just try setting the problem up, and then come back and we're going to continue the problem. Okay, hope that you tried setting this up. It says, in the figure below, WN is the bisector, so I would have marked that. Find the length of NO, so I'm going to mark that X since that's what I'm looking for. First thing that I would have done is set up a proportion. So SN is going to correspond to SW, and then NO is going to correspond to OW. Notice that we have an S and an S, an O and an O. That should always happen because that's the vertex that the two sides share. Now I'm going to fill in what I know. I have 4 root 2 over 14 is equal to x over 7 root 2. Now we're going to do the cross products. 14 multiplied by x is 14x. And then I have 4 root 2 being multiplied by 7 root 2. Hopefully you remember this. You are able to multiply the numbers outside the square root. So 4 multiplied by 7 is 28. And then the numbers under the square root. Root 2 multiplied by root 2 is root 4. And I still have this 14x. And I'm going to continue this up here. 14x is equal to 28 multiplied by 2, because root 4 is the same thing as 2. 14x is equal to 56. Dividing by 14, I get x is equal to 4. So in this case, NO is 4. Okay, we're going to do one more example. This one we're going to do together, or we're going to set it up together at least. It says find the length of OY if JY is equal to 20 in the figure below. Okay, so we have an angle bisector. So we have these two congruent angles. We know that JY is 20. And you're asked to find OY, which is marked as X. So here's the difficult part, is we don't have JO. But we do know that JY is 20. If the entire segment is 20, but OY is X, then JO is going to be 20 subtract X. 20 subtract whatever OY is. So if OY is 14, then JO is just going to be 6, because they have to add to be 20. Now let's set up our proportion. We have JO corresponds to J, I'm going to add a letter there, JM. OY is going to correspond to YM. Now let's fill in what we know. JO is 20 subtract X. JM is 7. OY is X. MY is 13. Let's do our cross products. 7 multiplied by x is 7x. That's equal to 20 multiplied by 13 is 260, and then subtract 13x. Adding 13x, I get 20x is equal to 260. Dividing by 20, I get x is equal to 13. So in our figure, OY is equal to 13. Okay, so today we learned 3 proportionality theorems, 3 theorems we can use to set up a proportion and then solve for missing sides. When you come into class, we're going to do a few examples.